Welcome to our last unit of the year. It's on transformations. So a transformation is an operation that moves or changes a figure in some way to produce a new figure. The new figure is called the image. The original figure is called the pre-image or the original figure, but you need to learn the words image, new figure, pre-image, the original figure. This is the way that we can write them. Prime notation means that I write triangle ABC goes to triangle A prime, B prime, C prime. We represent the word prime with those little apostrophes. If they stay the same letters, then that's what you use your prime notation. Now down here at the bottom right here, sometimes they change letters. So the first one is our original figure and it points to going to our image. So triangle ABC is the pre-image and triangle PQR is the image. Okay, transformations is a broad name, and basically there are four types of transformations we'll look at. There are reflections, rotations, translations, and dilations. A reflection is when you take a figure and flip it. A rotation is when you take a figure and you turn it. A translation is when you take a figure and slide it. And a dilation is either an enlargement or a reduction. We will be taking a day for each one of these and looking at each one of these. Okay, here are four pictures. We have to decide which type of transformation it is in each one. So kind of look at it for a second and see if you can figure out which one it is. The very first one, I made the figure bigger, so it's going to be a dilation. The second one, you can see the little arrow right here takes and turns the figure. So when we turn the figure, it is a rotation. And then the next one, we took the figure and we are sliding it to a different location. So that makes this one a translation. And finally, that last one is just like it looks. It is a reflection because the zebras can see themselves. So four types of transformations: reflections, flips, rotations, turns, translations, slides, dilations, enlargements. A little more vocabulary. Congruency transformation is a transformation that changes the position of the figure without changing the size or shape. That should make sense because that's what congruency meant. It meant that the size and the shape were exactly the same. Now, a more geometric name for that is called isometry, which is a transformation that preserves lengths and angle measures. So, because an isometry preserves lengths and angle measurements, and a congruent transformation says it keeps it the same size and shape, that means an isometry and a congruency transformation basically mean the same thing. So you need to understand that if they say isometry, they're just saying it keeps itself the same size, the same shape. The pre-image and the image will both be congruent to each other. Okay, the first transformation that we're going to look at is a translation. A translation is a transformation that moves every point of a figure the same distance in the same direction. So I have a little picture right here that shows it, and this particular one took and it moved it A direction to the right and B direction up. So what we're going to learn this year about is how to write it. A coordinate notation for a translation says you begin with your point, x, y, and then over here, since it's positive going to the right, it'd be plus some number, and y plus b would be that it's going up some number for b as well. So coordinate notation, whenever they say write things in coordinate notation, because we're going to learn two types today, this is coordinate notation. And I'll show you an example of it right now. Okay, so now we have an example. Graph the quadrilateral ABCD with the vertices -1, 2, B is at -1, 5, C is at 4, 6, and D is at 4, 2. Find the image of each vertex after its translation, and then graph the image using prime notation. So I'm going to graph all my points. So A is at -1, left 1, and up 2. B is at -1, 5, so -1 and up to 5. So that was my A, and this one was my B. C is at 4, 6, so to the right 4 and up 6. Right, 4 and up 6, that's my C value. And then to the right 4 and up 2 would be my D value. And I'm just going to connect the dots to make it look like it is a quadrilateral. So there's my figure. Now what the translation says is says take the x and go plus 3. Well, plus 3 means take it and move everything right 3. And then it says y minus 1, so that means take everything and move it down 1. So what that means visually I will do, because I'm going to teach you both visually and with coordinates. Visually that means I would take point A and I would move it to the right 1, 2, 3 and then down 1. And then I would take, and that would now become A prime. And then I'd take B and do the same thing, right 1, 2, 3 and down 1. So that would be my B prime. Same thing with C, right 1, 2, 3 and down 1. That'd be my C prime. And finally D, right 1, 2, 3 and down 1. So this would be my new figure. Okay, I'd be going there, same quadrilateral, same size, same shape, it just slid over some. Now to do it without graphing it, I would take A's point, negative 1, 2, and I would take A and I would add to it 3 to the x value and negative 1 to the y value. So negative 3 and 1 makes 2, and 2 minus 1 makes 1. So A prime is at 2, negative 1. If I go look at my graph, right 2, negative 1, that is the correct answer. Same thing with the B value. There's my point. I add 3 to the x, and then I take away 1 from the y. And when I do that, I get B prime is 2, 4. And then on the C one, I have 4, 6. I add 3, subtract 1 from the y value, so I end up at 7, 5. And finally for D, I do 4, 2. I add 3 to 4, and I subtract 1 from 2, so D prime went 2, 7, 1. So I can do it through points if I like, or I can do it through graphing. A translation theorem says a translation is in isometry. Remember, isometry means it just stays the same size and the same shape. So in my example right here, they want me to write a translation rule and verify its congruency. So to write the rule, it is x, y, the point x, y, goes to, so I have to decide what am I doing to the x value. So I pick one of the points, A, B, or C, and I move it from A to the prime. So 1, 2, 3, 4, so I went to the left 4, and then on my y value I went up 1, so plus 1. So that would be my rule. xy goes to x minus 4, comma, y plus 1. I have my rule. To verify that it is a congruency, remember we had 5 ways: side, angle, side, hypotenuse, leg, angle, side, 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 and angle, angle, side. Well, since these are vertical and horizontal lines, I know that that's the right angle, and so is that. So I've got one angle. I'm going to use the easy way. I'm going to count the length from A to C, 1, 2, and I'm going to count the length from C to B, 1, 2, 3. Then I'm going to do the same thing on my original triangle, 1, 2 for AB, and 1, 2, 3 for BC. So they both have the same size, and what property did I use? I used side, angle, side. So I have now verified that it is a congruency. It didn't say me to do a full proof, it just said verify it, so there's my verification. Another way to talk about translations is to use vectors. So this is the second way. I told you we're going to learn 2 ways to write them. One was coordinate notation, the other one is going to be vectors. A vector is a quantity that both has direction and magnitude, and it is represented in the coordinate plane by an arrow drawn from one point to another. So that is my vector. The initial point that I start at is the starting point. The terminating point is the ending point. To name a vector, you use the initial and the terminating point. So point F right here, this is my initial point. Point G here is my terminal point because that's where the arrow is. So I started at F and I went to G. Now this is not just a ray, okay, it's a directional thing that tells me which way to go and how far to go. When you name a vector, you use the initial point to the starting point, to the terminating point, and you draw a, almost looks like a ray, but it only has the one side. So we have now learned how to make a line look different than a segment, look different than a ray. Now we've got this one here, which is a vector. So it's very important what you put over two letters because it really defines what it is you're talking about. A line, a ray, a distance, a line segment, or in this case, a vector. So on a vector, it's just the top piece of the arrow. So my vector here was vector FG. Now in a vector, you have a horizontal component, which is your movement going to the right or left. If it's positive, it's to the right, or negative, it's to the left. So in this case, I'm going to the right 5, and then I'm going to go up 3 units. So my vertical component is my movement either up or down. So as I go up or down, it's going to change my movement. So up is positive and down is negative. Now, instead of writing the xy goes to x plus something and y plus something in coordinate notation, we use vectors and we write them in component form. Notice the brackets, how they just bend. So it's not the curvy parentheses, it has to be this type, because if you use the curvy ones, that's a point, and so we got to differentiate between a vector and a point. So we use these, and the first one is always my horizontal component, just like in a point. My B is my value, my vertical component. So in this particular one, it's saying I want to go 5 units to the right, and then I want to go up 3 units. So when I go to right my point, I write 5, 3. I don't have to put the x's in there, I don't have to put the y's, it's just the two numbers. That means write 5 and go to up 3. Okay, so translations and vectors. Component form is when I use the vector notation, the A and the B. Coordinate notation is when I use the xy goes to x plus something, y plus something. Remember, if you were going to the left or down, it would be negative. To the right or up, it would be positives. And just remember, right and left is x values and up and down is y values. Now, I thought this is kind of important to realize that it means different things. Right here we have our vector notation, and right here it's a point. So it does matter what type of parentheses you use to put around your point. Now, down here I've got 2 examples. We're going to do one of them right now and then leave one of them for class. So on part A, it says to name the vector. So the arrow's at C, so that means B is my initial point. So when I name this, I start with B and I go to G, and it's a vector, so I have to draw this type of an arrow above it. So that means vector BG, I have now named it. Its component form is how far did I move. So my component form, that type of bracket, and I went 1, 2, 3, 4, 5, 6, 7, 8, 9, and it was positive, and then I went down 2, so since I went down 2, it would be a negative, so 9, negative 2 would be the correct answer for my component form, and BG would be my 9 minus 2. BG is my name of my vector, and then 9, negative 2 would be my component form. We'll see you in class tomorrow. Come ready to work.